Broadcast. Going live. All right. Hi, everyone. Welcome back to the Technically Developers Conference. I am Julie Zeglin. I'm Technically's managing editor, and we are live. We are kicking it off with Daisy Kidd Henderson, who you will see on your screens now as well. She is a Comcast software engineer. And Daisy, you are going to be talking about zombie code, hidden wisdom from a dead language on a journey to automate the impossible. So this talk explores hidden wisdom discovered while delivering a business critical project and how those lessons can help us become better engineers, leaders, and innovators. The only catch is that it required using a dead programming language to automate an application that was designed specifically to prevent automation. So with that, I will disappear and let you take it away. Thanks, Daisy.
Awesome. Thank you. Okay, hello everyone, and I apologize if you see me looking over. I've got my slides on another screen. So we will get started. Who am I? Hello, my name is Daisy Kidd Henderson. I'm a software and develop engineer for Comcast Labs in Denver. What Labs kind of does is we look at new and emerging technology anywhere from 6 months to 10 plus years down the line to see if there's any potential use cases within the business. We also go out to all different parts of the business and see if we can help them solve some of their challenging and what they've deemed kind of unsolvable problems. My team likes to call me the MacGyver. I have lots of fun playing around with robots and brain-computer interfaces, as well as advanced computing technologies. Also, fun factoid about me, I enjoy jumping out of perfectly good airplanes, as well as base jumping. So with that, we will get started. So we were approached by the infrastructure team within Comcast to essentially see if we could help them. They realized they had no real centralized system across all of our data centers and head ends for inventory or even floor plans. Each facility kind of had their own way of doing things and inventory tracking. And they've been working on implementing a data center infrastructure management tool to kind of rectify the situation, but they were in over their heads. Floor plans were still pretty non-existent, and they asked us if we could help anyway. So after sitting down and kind of doing some brainstorming and some research, we decided to go with a LiDAR computer vision process and vendor to help us map the space. So what that process we kind of formulated looked like was we would take a LiDAR scan of the space, and this could be done by any data center technician with an iPad. It only takes about 10 minutes and requires pretty minimal training. From there, the vendor would give us a DWG, which is an AutoCAD file format, and CAD stands for computer aided design. They'd return us a CAD floor plan. And if you can see here, there's actually labels on all of the racks, the server equipment racks as well, which was great for us. From there, we would need to figure out a way to get that DWG into the correct format for our DSIM tool, kind of looking something like this. And then from there, that CAD DWG file could be uploaded into the DSIM tool and look a little bit like this. And the DSIM tool, if the file was in the correct format, would automatically recognize all of the objects and the labeling as well. So we kind of had a plan there, and now we had to actually figure out how we were going to do this. So one of the big challenges here was translating the file into the correct format, because as you guys saw, the CAD file we got back from the vendor was a 3D drawing created in AutoCAD 2020 and lacked some of the metadata needed for this DSIM tool. Now, this DSIM tool had way more requirements than we initially expected. It required a 2D drawing, an AutoCAD version 2011 or below, with a lot of crazy metadata tied to certain objects and a really convoluted, kind of confusing coloring and layering scheme for all of the different objects in there. So essentially, from that, I thought that this was going to be the perfect harmony. I had actually gone to school for mechanical engineering and had never really gotten to use any of that knowledge. And the CAD space and the software engineering space seemed like the perfect pairing. But unfortunately, I was deceived. After spending countless hours trying to implement in Python or C, we realized that AutoCAD was extremely closed off. It essentially, there we go. It essentially doesn't allow any manipulation within the AutoCAD system, and it doesn't have any of the Python or C tools, doesn't really have the functionality that we would need. So from there, we luckily found AutoLISP. And AutoLISP is a specific CAD dialect of Lisp. And it can deal with, and since it's automatically integrated within AutoCAD, AutoCAD comes with it, it can give us that deeper manipulation. So, well, it was a little bit challenging, and I'd never really heard of AutoLISP. I figured that, you know, this is just another language. Figure this out. Can you guys still see my screen? Oop, it looks like I got booted off. So let me just quickly get this back. Back to where we were. Apologies for that. So from here, I decided to dig into AutoLISP. So something that I was told really early on was that it's easier to use and learn than other programming languages, which I later would come to find out is definitely not the case and was definitely written by somebody who has never programmed in Lisp. So let's start with some origins of Lisp. It was originally defined in 1958, and Lisp stands for Lisp processing, not lost in stupid parentheses, as my team would lead you to believe after all of my yelling and frustration. It's actually the second highest, oldest programming language, right behind Fortran. And with that comes some uniqueness. So digging into what AutoLISP actually is and the history there. So in 1983, it was originally created based on a very, very early beta version of XLisp. And in 1986, it made its AutoCAD official debut in version 2.18. And from there, it was the primary choice of language to manipulate some of that AutoCAD structure until 1995, when AutoCAD decided that Visual Lisp was the way to go. And it had its own built-in IDE, was a lot easier to use. You didn't need as much Lisp knowledge until 2014, when they decided to deprecate it. So it was back to AutoLISP, which hadn't been maintained or updated since, and I will disclose my age here, since before I was born. So some of the challenges that AutoCAD presents is that it's a really complex system. You can think of AutoCAD kind of like a visual wrapper for a huge proprietary underlying data structure. You can see just an example of the object model on my screen right now. This is just one tiny slice of the wider database of AutoCAD. And AutoLISP actually has the ability to manipulate the underlying AutoCAD database, which was exactly what we needed. Now, AutoCAD was designed by people who specifically didn't want it to be automated. Whether that be in Lisp or Python or C, it's incredibly closed off and really challenging to actually go about automating something like this. So how AutoLisp interact are based on these things called association lists and group codes. Essentially, there are values. You can see an example for the circle group codes that are paired with group codes. So 10 here is the center point for a circle. And these indicate the properties. They're called dotted pairs within AutoLisp, but you can think of them like key value pairs in a map. So digging into this, I was a little bit overwhelmed initially, but I still thought I could figure this out. And I started with the most basic thing I could think of. Let me figure out how to just draw a circle in AutoCAD. So this is how you create a circle within AutoCAD. We start with our function definition, which is circle example in this case. And then we move on to the entity make. And within that is a list of a whole bunch of different values that when you're looking at it, you can be like, okay, I can understand circle, but I don't know what the rest of that means. So that first chunk of parentheses, that 0 is actually the group code for the object type. And that period indicates the dotted pairs. So that key of an entity type is paired with circle. This next chunk of parentheses is about group code for the center point. And that next chunk of parentheses, that 110, that is actually the X, Y, and Z coordinates of the center point. From there, we move on to the last chunk of parentheses, and 40 is actually the group code for radius, and 5 is the unit of measure. This would be set, either you can do it through AutoLisp, I didn't know how at this point, or within the file itself. So you can tell there's a lot going on in here, and there's a lot to I thought I could approach this with my previous method of how to learn a language or a new code base, which first step, look at the code base, move on to reading the documentation, mess around with the tests, see if I can figure some stuff out. And when all else fails, we go to our savior, as you all know, Stack Overflow. Now, I kept trying to, fit Lisp into my previous method of doing things, but it was clear it didn't work. What it ended up turning into was getting lost in the stupid parentheses, trying to figure out actually what was going on, frantically Googling to try and see any documentation or any knowledge about AutoLisp, come back to the code and completely forget where I left off or what all of these group codes meant, and then the inevitable panic. So early on, the first big key takeaway of this presentation is, as we've all heard, write good code, and when that fails, write good comments. It became really, really clear to me that I could not even take a break for lunch and resume development in AutoLisp without creating probably an excessive amount of comments on the actual code, because I couldn't keep straight what all of the group codes were and what values they took in. A big reason why Lisp is challenging and why I was struggling so much is because Lisp is technically considered homo-iconic. Now, I know this can produce a lot of knee-jerk reactions and has produced a lot of controversy in the software space. Homo stands for the same, and icon stands for representation. And while people like to say Lisp and AutoLisp are homo-iconic, real homo-iconicity is actually that your internal interpreter and external representations are the same, which means that in a perfectly homo-iconic language, source code can be run immediately without any interpretation. So Lisp and AutoLisp still require some interpretation, but it's where the idea that your code is the same form as your data comes from. So if we're going to dig into the semantics, it really is a partially homo-iconic language. and that code and your data is the same structure is a really, really big challenge to not only kind of structure your code, but even figure out where you're going. I realized during all of this initial learning phase that I was really fighting the language. The no syntax is incredibly difficult. All of the parentheses are overwhelming. And not to mention that there were no experts, not only within Comcast, but actually in the larger, internet tech sphere. There are very, very few people who actually use AutoLisp still, and they're mostly mechanical engineers just automating a very, very few select pieces. In this point, there's big stakes and nobody could help me out. And in my despair, I've decided to do what we probably all have done in times of high stress and impending deadlines and doom, which was browse the internet on a semi-related tangent so you can convince yourself it's not procrastination. And while I was doing that, I actually came across an article on NASA's Deep Space One. It was their first venture into the Deep Space Network. It launched on October 24th, 1998. What's really cool about this, it was actually the Jet Propulsion Laboratory's first dip into the water with their remote agent experiment, which is called RAX. It's essentially their very toward creating autonomously flying spacecraft. And it was built on a custom Harlequin version of Common Lisp. Everything went fine until 6 months after its launch on May 18th, 1999, disaster struck. What happened was the piece of Lisp code was actually going to control the spacecraft for 2 days while experiments were being run by the scientists on the ground. But there was a race condition that had escaped testing that actually deadlocked the entire system. So this is actually what the RAX error was in Lisp. And I don't want to, we'll actually go to the Java abstraction of that Lisp code. What happens is this run loop. It starts with that if statement. And essentially it's saying, hey, if the event counter has not been changed, then we need to wait, in case a new event came on. The issue was that if a new event occurred after that statement, but before this event.wait for event, and essentially the process would just go to sleep even though a new trigger had been sent, and it caused a complete deadlock of the system. And this was actually, these 2 days were what the spacecraft was built for. It was built for those 2 days of experiments. Luckily, Lisp came to the rescue with its read eval print loop, or REPL. So essentially what they did was they took a clean room experiment on the ground to quickly identify the error, and then were able to debug it using this Lisp REPL, which essentially means that how Lisp REPLs work is you start a language processor, you type in an expression at the prompt, wait for it to evaluate the expressions, and then print the results before prompting another expression. And using this kind of REPL way of doing things, they were able to unlock the spacecraft in 2 commands. And so this is a dev quote from somebody who actually was the lead programmer for troubleshooting this error. Debugging a program running on a $100 million piece of hardware that is 100 million miles away is an interesting experience. Having a read eval print loop running on the spacecraft proved invaluable in finding and fixing the problem. This was really a light bulb moment for me, is that I realized I needed to shift my perspective and how I had traditionally done development to a completely different way of thinking. I'm a huge fan of test-driven development, and I realized that that needed to be buried and tucked away while I was in the Lisp sphere. So essentially, the language and the runtime system for Lisp are designed from the ground up with the assumption that you're actually going to develop programs by starting the language engine and talking to it and teaching to it how to be your program interactively. and changing it while it runs instead of the standard, you write your code, you compile, and then you run. And different languages can do some things with this REPL. I'm sure you guys are all familiar. But the thing that makes Lisp and AutoLisp different is that everything is done in REPL. Is that even Lisp IDEs, they're all just the read, eval, print loop under the hood. So with this new shift in perspective, I really started looking at development as an interactive experience instead of a kind of a cooking experiment. It wasn't, or I guess baking. It wasn't you measure everything out, you mix, you bake, you eat your cake. You're eating your cake while you're adding in flour and changing it as you go through. It encourages kind of line by line debugging and compartmentalizing of how you think about errors. And I also found that writing a piece of code, running it, and immediately getting an error is way quicker than the idea of writing and trying to run it, finding an error, debugging, and then trying to see if there's any other errors. It really encourages kind of being present in the moment. So we'll take kind of an example of, systems that you guys are probably all familiar with. Is that, let's say you have a database function that is tied to a controller and is called through a REST API. Now, your task is to optimize that query. The typical process would be you'd make your changes to the database function. You'd read load automatically or manually, I guess, if you really wanted to. Let the code process and then check the results of the REST API. With REPL and the way Lisp development works, you can actually skip all of this boring part and just bring that database function and its dependencies to the read, eval, print loop and edit it in real time. So that leads to the perspective shift of operating in terms of full program, which I think is the standard way of development today, to operating in terms of function. It really is, I kind of joked with my team, it's really a Zen experience of being present in the moment of exactly what you want to write and write it then and there, which leads us to our key takeaway number 2. Fail early, fail often. This is a completely overused motto, I know, and I'm sure you guys have all heard it a million times, but how often do we actually embrace this model down to every day and down to every piece of code, every function, every method that we write? Not very often. But if we can kind of embrace this fail early, fail often method of interactive development, it can really help us grow our code in a much more robust way. So this was the perspective shift, because Lisp really lends itself to being the programmable programming language, is that it takes a really bottom-up approach to grow your code from the start. What's really cool about Lisp, and something that it kind of showed me and shifted my perspective, is Lisp is really a great mechanism for you as an engineer. You think about a problem, and Lisp, you can see really closely under the hood of what is happening with all that data and immediately respond or change your code, and it will automatically kind of reload as you go. So back to the problem at hand of developing this missing link, this code to take that vendor received file and translate it into the requirements for our DSIM tool, I decided to take a new approach and go line by line from AutoCAD into AutoLisp. And how that looked was I started initially by taking a file, and since I did have mechanical engineering experience, I was able to take that file and manually change that and translate it into a file that could be consumed by our DSIM tool. And I wrote down every step of the way. Then I went through the process of coding each and every one of those individual tasks that I did. And it was really cool because I could take a file, I could write a manual task that would, maybe need to be halfway through the program, but I could actually run it right then and there and see if it worked. And after I got that wrapped up, I then took all of that manual code of that process and I was able to wrapper it and automate it. So we can kind of see that in action here. So what you're seeing is actually the LISP program taking every single object and entity within the file, exploding it, re-embedding it with metadata, recoloring and rehatching what needs to be recolored or rehatched, and then combining it all and producing this file. It was actually one of my, it was cool to see and to watch it work on the screen, and it was definitely a huge relief for me. So that leads us to our last takeaway of this, of making your language work for the problem. I spent so many hours and development cycles trying to fight this language and move it into kind of a structure that I was used to for development. And we oftentimes, as engineers, try and kind of craft our engineering problem around our chosen language, whether it be Go or Python, when maybe that's not the right fit. Instead, if you can make your language work for the problem and find the language that will help you solve that problem the best, it can really help not only down the line, but also as you're developing, get a better understanding of the end-to-end program you're trying to develop. So kind of as a conclusion to automating the impossible, because AutoCAD is so resistant to being automated, it was quite the challenge and took about 6 months to get to this point. But I was able to deliver the results of that missing link between the vendor files we received and our DSIM tool. And I also found out the really cool thing about a completely unmaintained, unupdated programming language, and especially with Lisp, is that it's incredibly low maintenance. Is that I can, well, the wrapper might change or the Python script that makes this run might change. The Lisp code isn't going anywhere. So I'll leave you kind of with this funny joke. The comics for Lisp are quite abundant. And from there, I'll just kind of conclude with the 3 big takeaways to what we can learn from Lisp and AutoLisp to help make us better engineers is really writing good code, but more importantly, writing good comments, because readable code is the only way. And while you might think it's readable for you or your teammates or 6 months down the line, who knows? It could be deprecated 10 years down the line and some poor engineer is trying to understand what's going on and there's no documentation. Number 2 is the idea of really embracing that fail early, fail often motto down to every single line of code we write. It's not only a really fun shift to kind of spice up the engineering and day-to-day coding, but it helps us solve those problems better. And the final point is to make your language really work for the problem instead of crafting your problem to fit your chosen language. And so with that, I do believe that we are close on time. So thank you all for joining. If you have any questions, feedback, or comments, you can find me at Twitter at Daisy the Kid. And my email is daisy_henderson@comcast.com.
Awesome. Thank you so much, Daisy. That was awesome. Everyone who's here, thank you for attending the Technically Developers Conference. We are going to head over to the Urban session on the retail app that brought together product and engineering. So we'll see you there shortly. Thank you. Thanks again, Daisy.
Thank you.